Hi everyone. So continuing on the topic of chemical quantities, we're now going to look at what's called percent composition. Now, if you recall, the law of definite proportions states that the masses of an element in a compound are always in the same proportion. So that means that a compound always has a fixed ratio or fixed quantity of the masses of elements within them. Percent composition refers to the percent by mass that an element makes out of the compound. So it is really just the mass of an element out of the entire thing. So if we wanted to express it as an equation, our percent composition is really just a percentage, and it's going to be the total mass of an element divided by the total mass of whatever compound it is, and of course multiplied by 100 to make it a percentage. So let's see an example of how to calculate percent composition. So we're going to do this for ethane, whose chemical formula is C2H6. So usually whenever we're discussing a general question like this of finding percent composition, we are going to look for the percentage of both elements here. So the percent composition of hydrogen and that of carbon. So if we work through the periodic table and calculate the molar mass of ethane, we find that its molar mass is 30.08 grams per mole. So that means the percentage of carbon would be the mass of carbon out of the mass of the entire compound times 100. Similarly, the percentage of hydrogen would be the mass of hydrogen out of the mass of the whole thing times 100. So here we're talking about the total mass of carbon. There are 2 carbon atoms, so that means the mass of carbon would be its molar mass, 12.01 grams per mole, times 2, since we have 2 of those, over the molar mass of the entire compound, times 100, gets us a percent composition of 79.9%. So that means in ethane, this is approximately 80% carbon by mass. We can do the same thing for hydrogen, taking its molar mass of 1.01, multiplied by the fact that there are 6 hydrogens in this compound, divide it by the total mass of the compound, times 100, and we would get 20.1%. So that's how you find percent composition. It is just taking the total mass of an element divided by the mass of the compound. And of course, these percentages should all add up to being close to 100%. Now let's take a look at another example in using percent composition. So in this example, we want to calculate the mass of hydrogen in 20.2 grams of sodium hydrogen sulfate. So we know that there is hydrogen present in this compound, and if we want to find the mass of hydrogen in this 22.2 gram sample, well, we need to know what percentage hydrogen makes of this compound. So we would need to first find the percent composition of hydrogen, because if hydrogen is a certain percentage by mass of this compound, then that means the mass of this hydrogen is also the same percentage of the sample. So our formula for sodium hydrogen sulfate is given as NaHSO4. Now we're looking for the percentage of hydrogen that's present in this compound by mass. So that means we're going to want to find the total mass of hydrogen and divide it by the mass of this formula of this sodium hydrogen sulfate. And once we know the percentage, then we can use that with the mass of the sample. So there's only 1 hydrogen atom present in this compound, so it's going to be a mass of 1.01, the molar mass of hydrogen, over the total molar mass of the compound, which is 120.06. Times 100 gives us about 0.8% hydrogen by mass. So what this tells us is that hydrogen makes up 0.8% of the mass of the sample. So if I have a 20.2 gram sample of sodium hydrogen sulfate, well, hydrogen makes up 0.8% of that. So hydrogen would be 0.170 grams of that sample. So we can also use percent composition in order to find out what percentage an element would make up of an entire sample, knowing what percentage by mass it makes up of the compound. Let's take a look at another example of where we can use percent composition. Let's determine the mass of copper in grams that can be extracted from a 1.58 kilogram sample of an ore that contains 44% copper. And we're going to look at two scenarios. One, where extraction is 100% efficient, so we get every last bit of copper out of it. And two, where the extraction is only 80% efficient. Now here the work has been done for us, and we already know that copper makes up 44% of the sample by mass. So if we're assuming 100% efficiency, that means we're getting the full 44% of this 1.58 kilogram sample. So in part A, we have 1.58 kilograms of ore. Multiply that by the fact that copper makes up 44% of this, and we get that copper is 0.695 kilograms of the sample. Now we are asked to find this in grams, so this just comes to being 695 grams of copper. Now in the second scenario, we're only getting 80% of that. So that means if at 100%, we would acquire 695 grams of copper with 100% extraction. In part B, we're only going to see 80%. So we're just going to get 80% of this 695 instead. So that means we'd only be able to get 556 grams of copper, assuming that it's only 80% efficient. So there you have it. This is how percent composition can be utilized. It can be utilized to find what mass of a certain element makes out of a sample. And it's really just taking a percentage, so a part of a whole, the mass of one of the elements out of the total mass of the compound.